So, Srikal students, so today we are discussing lecture number 3, effect of change in temperature. We have discussed in the first lecture about what is matter, philosophical view, old view, new view. In the second lecture, we discussed some terms like sublimation, vaporization, fusion, melting, etc. related to phase change, or we can say related to change of state of matter. We also studied that how the matter state can be changed, and we understood that the change in the state of matter can be accomplished either by changing the temperature or by changing the, yes Sargun, number 2, the change, the phase change or the state change in matter can be accomplished either by changing the temperature or by changing the pressure. These are two important correct variables. By changing them, the phase change or state change from solid to liquid, liquid to gas, gas to liquid, gas to solid, whatever it is, can be achieved. Now, we have seen that as the matter is in solid state, from solid state, if we supply temperature, it becomes liquid. From the liquid, if we further supply temperature, it becomes gas. Why? What happens internally that this change happens? Let us see. Students, whenever a solid is heated, we have taken example, let's say of ice, chunk of ice, and we are heating it with a burner, and we saw that the solid ice gets converted into liquid. It's the same case with most of the solids, elements, or other substances also. If you heat them at a particular temperature, and pressure, they will start fusing, they will start getting melted. So they will melt into from solid to liquid. What happens? Now students, we have also seen that entire matter is made up of very tiny particles that we have seen in the first lecture, right? Entire matter is made up of tiny particles which differ in, any student can tell, which differ in shape, size,
Size.
as well as
Size,
nature. Entire,
nature
entire,
of
entire matter is made up of tiny particles. These tiny particles, we have also seen, we have also observed that they are always in motion, which I called as lattice vibration. If you remember, lattice vibration means in every matter, in every solid especially, the particles are arranged in a particular fashion. They are not randomly arranged. They may be arranged like this. We have also seen the case of graphite and diamond, how the entire, millions and trillions of particles of carbon are arranged in particular fashion in graphite. They are arranged in particular fashion in diamond, right? uh, Now students, all the particles, this can be considered as their mean position. They are always vibrating about their main position. They are always vibrating about their main positions. Now, when the solid is heated, the kinetic energy of these particles increase. Kinetic energy is, that half m v square. When the temperature increases, the velocity, you know how they are vibrating, that increases. So the kinetic energy increases, and when the kinetic energy increases, you know they are vibrating at greater speed. Now the energy supplied by the heat, whatever heat we are supplying to the, like this heat we are supplying to the solid. One more thing I want you to tell students, suppose we are talking about water. Let's say we are talking about water or we are talking about ice. Whether you talk about water, solid state of water, Whether you talk about, liquid state of water, whether you talk about ice, the solid state of water, or whether you talk about steam, that is the superheated state, or gaseous state of water. These are three states of water. The one molecule, every molecule, the most fundamental particle of water is H2O. This is a chemical formula of what is the meaning of H2O. That means every oxygen atom in the molecule of water is bonded to two.
Hydrogen atom.
Very good. Every atom of oxygen is bonded to two hydrogen atoms. Very good. Right, Nishan? Now, even if you take 1 gram of water, or you take 1 liter of water, or you take 1 gallon of water, everywhere you will see the structure is like this. Now, I told you yesterday what is the meaning of bond. Bond is basically the forces of attraction between the different atoms or same atoms. Like we talk about carbon dioxide. Here, one carbon atom is bonded to two, come on students, oxygen atoms. This is CO2.
Atoms.
Yeah, this is a basic structure of carbon dioxide. Now, students, interesting thing. This this we say
CO2.
is bonded to two oxygen atom. That means there is a bonding between carbon atom and two oxygen atoms. Here there is a bonding between one oxygen atom and two hydrogen atom. This bonding is what? Bonding means there are forces of attraction. Like, yesterday we discussed NaCl, namak. In case of namak, what kind of bonds are there? I told yesterday. Can anyone tell? In the namak,
Ionic bond.
correct. It is ionic bond. Now, and ionic bond are very, very strong. I told you yesterday. We will discuss later on when we study chemistry. We have not studied chemistry very well. Now we have to focus on chemistry. So, ionic bonds are very strong, and that's why the melting point of NaCl is very high. So, students, when the heat is supplied, these bondings become weak, sort of breaking off these bondings, you know, takes place. Okay. Now, what happens? The energy supplied by the heat. Heat is basically energy. This scientist Joule told us that heat is another form of energy, and that is the reason the unit of heat we say is also Joule. The unit of work is also Joule, and the unit of energy is also Joule. Very interesting. Okay. All right. Whether it is potential energy, kinetic energy, the unit is Joule. Unit of heat is also Joule. Okay. Now, once again, the energy supplied by the heat. I am supplying by heat to this ice. This energy overcomes the forces of attraction between the particles. These are the particles H2O. Now, the particles leave their positions. Whatever are the main position of the particle I discuss, they leave their main positions to some extent, and they start moving more freely. They have more free motion. They start moving more freely at certain stage, that is at the melting point. Yesterday we discussed about melting point. Now what is happening at melting point? At melting point we also discussed yesterday, students, if you remember, that melting phenomenon is a isothermal phenomenon. I'm using this word isothermal. Iso means same, thermal means related to temperature. Melting, fusion, condensation, or an isothermal phenomenon means these processes take place at constant temperature. It is very interesting to know. Yesterday I gave you a hint that we will discuss why the temperature is constant. It's so interesting, students, that if we are having, you know, if we are having some ice, you know, let us say the ice is at we are trying to melt the ice at 1 atmospheric pressure, that means normal pressure, and let us say the ice is at minus 20 degrees centigrade. It's very hard to just taken out of freeze, you know, fridge or freezer, minus 20 degrees centigrade. Students, just see an important thing. Whenever you start giving heat to this ice, you know, temperature will increase from minus 20 degrees centigrade, then minus 10 degrees centigrade is increasing, minus 5 degrees centigrade, and it becomes 0 degrees centigrade. Interesting thing happens at this. This is the melting point of ice. At 0 degrees centigrade, the isothermal process start. What is that isothermal process? Melting starts. Melting is isothermal, constant temperature. See, from minus 20 degrees centigrade to 0 degrees centigrade was not isothermal. The temperature is increasing as we are giving heat. So we can understand we are giving heat. See, there is a student, he is eating lot of food. Obviously, his stomach will become fat. People will start telling him, "Oh, come on, yaar, you are looking like a kaddu." So, if he is taking less food, he will be skinny. So, very simple. If we are giving heat, the temperature is increasing. We are able to see the direct effect of heat supplied in terms of increase in temperature. But student, why we are not able to see the effect of giving the heat at during the melting process? If we have seen yesterday, you know during the melting, the temperature of the ice remains 0 degrees centigrade, even if it takes 5 minutes, 4 minutes, or 2 minutes, till the entire ice is converted into water at 0 degree centigrade. See, ice was at 0 degree centigrade, the water is also at 0 degree centigrade, where that heat is gone. So today we are able to get a hint that heat, this is H2O, that heat is trying to break the bond between oxygen and hydrogen atoms. So initially that heat, when it was increasing the temperature, in we can say it was increasing the internal energy of the ice. When the temperature was increased, we can say internal energy of the ice was increasing. The heat supplied was doing this work. Now at this process, melting process, the heat supplied is not increasing the internal energy, but it's definitely doing some work. You see, heat in a car moves the car. Heat in a car, actually it is a heat which moves the car. Do you know, students, all the automobiles in the world, whether it is aeroplane, whether it is simple auto, whether it is scooter, motorcycle, they are driven, work is done. They are driven, and they also take us in the car or truck or bus. But what is driving them? Engine is driving them. And what is the input to the engine? Any student can tell? What do we supply to the engine of every automobile? We supply fuel, petrol or diesel. And if you just keep the fuel in the car, will it run? No, you have to set the ignition on. Ignition on means the fuel is burnt. When the fuel is burnt, spark plug burns the fuel, there is explosion, heat is generated. So interesting. This heat is basically driving all the automobiles. And this heat, that means this heat is doing work. And here, this heat is not increasing the internal energy during the melting, during the melting or fusion, and also during the vaporization. During the vaporization also, when there is a phase change from liquid to gas, the heat is again, trying to break the bonds further. So we got the answer to some extent today. So guys, now we came to know that particles leave their position, start moving more freely. At certain stage, solid melts and converted to liquid state. So this is what is happening in melting. Okay. Now students, again a certain temperature is reached. You know, if you keep supplying heat, a certain temperature is like, suppose we had ice, you know, it was at 0 degree centigrade, right? We supplied heat to the ice by the burner or by stove or something else, you know. So it first converted into 0 degree centigrade water, then temperature rose 40 degrees centigrade, you know, 70 degrees centigrade, 90 degrees centigrade, then 99 degrees centigrade. We are supplying heat. The heat is increasing internal energy. Internal energy E of the water. Temperature is increasing. We can see the effect of heat given in terms of increasing temperature. But strange thing happens at 100 degrees centigrade. If the atmospheric pressure is 1 atm, approximately equal to 1 bar, that is 10 raised to power 5 pascal. 1 bar is 10 raised to power 5. This is the atmospheric pressure, students. We observe it all on our head when we are on the surface of earth. So students, at 100 degrees centigrade, temperature again becomes constant. See that. If you started melting the ice from minus 20 degrees centigrade to, let's say, 120 degrees centigrade, it's a very interesting thing what happens. See how the temperature changes. First is minus 20. Here is minus 20 degrees centigrade. Minus 20 to temperature changes to first 0 degrees centigrade, right? Then at 0 degree centigrade it remains for some time, and then it temperature increases, and it increases to how much? 100 degrees centigrade if the atmospheric pressure is 1. And then at 100 degrees centigrade again entire liquid converts into vapor, and when the entire liquid has converted to vapor, again the temperature starts increasing. So this is the way, you know, the heating takes place, and then it becomes 120 degrees centigrade. This is how the temperature changes from minus 20 to 120. It's not like this. It's like this. All right. Okay. So here we can say the volume of the substance to some extent also changes. Volume also increases. We know that volume of liquid is more than volume of solid. Volume of gas is more than volume of liquid also. So, you know, now students, a certain temperature is achieved when the particles have enough energy to break free from the forces of attraction of each other. Now, I am talking about boiling. Already during melting, the forces of attraction between hydrogen and oxygen or any substance, you know, it become little weak, and then solid converted into liquid. Now still there are some forces. There are some forces, okay? And when boiling takes place, boiling is again constant temperature process. That is isothermal process. And what is happening, students? Now what is happening? Why it is isothermal? Why the heat supplied is not increasing in temperature? Because internal energy now is not increasing. What is increasing? Again, the heat supplied is trying to do work, as it drives all the automobiles. It does the work. It further, you know, breaks the bond between hydrogen and oxygen. Students, this is the reason the volume of gases is far more than the volume of liquids and the volume of solids. Why? ये ऑक्सीजन और हाइड्रोजन के बीच में जो बॉन्ड थोड़ा सा रह गया, बॉइलिंग जब हो रहा है, ये और वीक हो गया, ऑलमोस्ट ब्रेक हो गया, बहुत ज़्यादा कम हो गया. मतलब जहाँ 100% था सॉलिड में, यू कैन से 5% रह गया, यहाँ इससे भी कम रह गया. सो दे विल गो अपार्ट, hydrogen and oxygen, as they are free. You know, children which are not in the discipline of parents, so what they happen, they go far off places and they play. The bonding between those children and parents is very less, right? Similarly, the bonding between now oxygen and hydrogen atom is very less. So, you know, this is hydrogen and this is oxygen, and the bond is also very weak. That state is known as gaseous state. Okay, to sum up, what we can say, when it was liquid, now, when it was solid, there was strong forces of attraction between the constituent particles. We supplied heat, you know, The forces of attraction became weak, it became liquid. It further became very weak and it became gas. That's the reason the particles are, far apart, and that's why the volume occupied by the gas is much, much more than the volume occupied by liquid and then the volume occupied by the solid. Right? So we can say solid state, we heat it, it became liquid state, then we heat it, applied Q means I supplied heat, it became gaseous state. Now reverse. What reverse? If I'm cooling the gas, it becomes again liquid. If I'm further cooling it, it again becomes solid. So it can be concluded that state of matter can be changed to another by changing the temperature. So this we have completely seen the effect of temperature in today's lecture. You know, then we will see the effect of pressure in the coming lecture. Okay. Now one more thing. See that students, this is liquid state, right? This is solid state, right? When solid is converted into liquid, what is this process known as? Any student? When solid is converted to liquid by giving heat, this process is known as,
Sir, melting.
it's known as melting. Beautiful.
Melting.
Correct. Or it is known as fusion. Melting or fusion. Okay. Now students, when liquid is converted to gaseous state, this process is known as, any student?
Sir, evaporation.
Beautiful. So don't say evaporation. No, it's not evaporation. I will explain you different. Evaporation is a surface phenomenon. It's not volumetric phenomenon. It's vaporization. You know, conversion of liquid from liquid to gaseous state. Okay, students. Now, the gas can directly be converted to solid. What is this known as?
Deposition.
Oh, beautiful. And if solid can directly be converted into gas, that is known as,
Sublimation.
beautiful, sublimation. I'm so happy students are learning. This is deposition. Very right, students. Okay, now when the liquid is converted to solid, what is this process known as? This I did not tell you. Today I am telling you. This is known as solidification. Solidi Sorry, I'll be at 2 o'clock. You have to see this video again. I will upload now. I will ask you each and every question. Okay, lot of things at greater depth have been discussed at a very fast pace, so you have to listen to the video again. Solidification. And one more thing, gas into liquid. When I convert gas into liquid, any student can tell me this process is known as, yes, gas into liquid. There is a gas like water vapor, they become liquid. Imagine students, you are
Sir,
having,
Condensation.
condensation.
yeah,
Sensation.
you are having a bottle. Let's say you have this bottle, you know small bottle of cold, that can is there. Let's say, a can is there. On the outer surface of the can, you will see some droplets of water. This is a result of condensation. This process is condensation. How it happens? The superheated vapor of the water present in the air, they take some heat, they release heat, you know and they become droplets on the surface of the bottle can. This is condensation. Very good, students. Now we will discuss, uh, okay, I'm giving you one homework also. Try to search what is the difference between gas and vapor. Otherwise, I will tell you at 2 o'clock. Okay. Now, students, keep be there. I'm going to discuss one more thing.